What's up, everybody? Another video lesson. Mr. Kozad back again for yet another one. Today's topic is on standard form in quadratic functions. Okay, today we're going to look at how to identify all the key attributes like the vertex, the axis of symmetry, the y-intercept. We're going to sketch graphs. We're going to look at domain and range. We're going to do it all today, specifically with standard form. So buckle up, get ready to go, because we're going to jump right in. Okay, so with standard form in a quadratic, there's a formula that you should remember that you're going to need that tells you a few useful pieces of information. And that formula is negative b over 2a. Okay, we are going to use this, so this would be a really good thing to know. So you really want to know that, okay, and remember that because it's going to show up a few times. I'm going to show you where it shows up. So negative b over 2a is actually going to tell me the axis of symmetry. Negative b over 2a tells us our axis of symmetry. And remember, real quick review, if you have a parabola, which is the shape that a quadratic function in standard form produces, the axis of symmetry is a vertical line that passes through the vertex, and it cuts the parabola into two congruent halves, okay? Now, if the axis of symmetry passes through the vertex, that tells us that the coordinates of the vertex, the x-coordinate, is going to be that same value, negative b over 2a. Now, the hardest part, in my opinion, about standard form is finding the y-coordinate of the vertex. The way you're going to do that, you're going to take the function, and you're going to evaluate that function for the x value, negative b over 2a. Okay, that's the part that's going to take some algebra skills. Now, the y-intercept on standard form is actually really simple, okay? So think for just a minute about what would happen if we plugged a 0 in for x. Ax squared would become 0. Bx would also become 0. So we would have 0 plus c. Well, so your y-intercept is going to be c. So the y-intercept is super easy to find on standard form, okay? So let's practice this in a sample problem. So example 1, sketch a graph of the following function. Find the coordinates of the vertex, the axis of symmetry, the y-intercept, and the domain and range. And here's your function, okay? The first thing that we're going to identify is we're going to find that negative b over 2a value. So we're going to look at the equation and we're going to pull out the b value. The b value is 4, so we have negative 4 on the top, all over 2 times a, which in this case is negative 1. We simplify that. The top stays negative 4, the bottom becomes negative 2, and we simplify that to get 2. Now, that is the x-coordinate of my vertex, and it's also the axis of symmetry. So I'm going to actually start with the axis of symmetry. Okay, so my axis of symmetry here is going to be x equals 2. Now for my vertex, x equals 2 is going to be the x value of my vertex. To find the y value, I'm going to find f of 2, which means I'm going to substitute in a 2 for every x that I see. And then I'm going to simplify. So take a second and see if you can simplify this expression right here. Okay, be careful with the order of operations. Okay, so we're going to do 2 squared is 4, and then we multiply by negative 1. If you're going to make a mistake here, here's where you're going to make it. The negative is not being squared. Okay, so what we're going to do is we're just going to square the 2 and then multiply that by negative 1. So that ends up becoming negative 4 plus 8 plus 2 equals 6. So my vertex will be at 2, 6. Okay? Now the easiest part of standard form is the y-intercept. That's going to be at 0, c, and c in this problem is 2. Okay? Okay, so now let's draw a rough sketch of our parabola here. Okay? I always like to start with my axis of symmetry, which is over here at x equals 2. The vertex is at 2, 6, so that's somewhere in the first quadrant. The y-intercept is at 0, 2, so then I can reflect that point across the axis of symmetry. So it's equidistant. Remember, we want each half to be the same. And then we can draw a parabola that opens down like so. Now, we can also have identified this opening down because when the a value is negative, that parabola is going to be reflected across the y-axis. So that's another way that you can tell that it needs to open down. So seeing that it opens down allows me to do my domain and range. Remember, domain is left bound to right bound. Okay, the left bound is actually negative infinity. And the right bound is positive infinity. The range goes floor to ceiling. Okay, so the floor is negative infinity, and the ceiling is going to be whatever the y value is of the vertex. So again, range goes from floor to ceiling, and we use a bracket there in interval notation because the function actually hits y equals 6. Okay, that actually hits y equals 6. Okay, so again, hardest part of this problem is figuring out negative b over 2a and then using that to plug into the function to find your y value of your vertex. Okay, let's try another one. So example 2, exact same directions but new function. Exact same directions but new function. All right, so here's what we're going to do. We're going to take this function, we're going to find our negative b over 2a value. Okay, so negative b over 2a, we've got negative 1 in the numerator, all over 2 times 1/3. So when we simplify that, we get positive 1 on the top, all over 2/3 in the denominator. Okay, now you have to remember that when you divide by a fraction, that's the same as multiplying by the reciprocal. So this ends up being 3/2. Okay, so that tells me that my vertex, actually let's start with the axis of symmetry. Okay, that's the easiest one once you have negative b over 2a. So my axis of symmetry is at x equals 3/2. My vertex x coordinate is also 3/2, but we have to find the y coordinate. So to do that, we're going to take the function and we're going to plug 3/2 in for x. So this becomes 1/3 times 3/2 squared minus 3/2 minus 3. Okay, so I clean that up algebraically. Remember, when you square a fraction, you just square the top number and the bottom number. So that's going to become 9/4. Okay, and then 9/4 times 1/3 is 3/4. Minus, I'm going to change this to 6/4. And then I'm going to change this to 12/4. Just so I can have a common denominator and be able to identify what we've got here. So 3 minus 6 minus 12 is negative 15/4. It's negative 15/4. So that is the y coordinate of your vertex, negative 15/4. Okay. So then we're also going to find my y-intercept. I can sneak that in down here. I got plenty of room for that because it doesn't take much space. It's 0c, and c in this case is negative 3. Okay. Now, before I do domain and range, I find that it's kind of easy to draw a sketch of the graph first. Okay, so my axis of symmetry is over here at 3/2. My vertex is down in quadrant 4. It's 3/2 negative 15/4. My y-intercept is at negative 3. Okay, so you can tell that that parabola is going to open up, and it's going to be kind of wide, which is fine. Remember from the last problem, a trick to know if it opens up or down is you look at the a value. The a value is positive here, therefore you know it's going to open up. So the last attributes that you need on this graph are the domain and the range. The domain, again, is from negative infinity to positive infinity. Remember, domain goes left bound to right bound. And the range goes from floor to ceiling. So the range, the floor is negative 15/4, and the ceiling is infinity. okay? So there's one more problem that I want to go over with you here. It's how to work backwards from a set of attributes to a quadratic function in standard form. Okay, so let's read this together. It says write two possible, okay? So that's interesting. So we're going to actually have two answers here. Two possible quadratic functions in standard form that have an axis of symmetry of x equals 3/2 and pass through the point 2, -2. Okay, now here's kind of what we're going to do here. We are going to talk about what this fact that the axis of symmetry equals 3/2, what that means. Now, the very first slide we did, I told you there was an important formula that you're going to need to remember. The axis of symmetry is equal to -b over 2a. Okay, so basically what we want to do is we want to look for combos of a and b so that when I plug in -b over 2a, I get that to equal 3/2. So let's brainstorm some combos of a and b so that when I plug them in -b over 2a, it simplifies to 3/2. I'll start you with one and then let you brainstorm another one, okay? So let's start with a equals 1 and b equals -3, okay? A equals 1, b equals -3. Okay, think about it. If I plug a 1 in for a, the bottom becomes 2. If I plug a -3 in for b, the top becomes 3. So that would equal 3 over 2. So that combination works. Let's come up with another combination. Okay, we could let a be 2 and b could be -6. Okay, so again, when I plug a -6 in the top, that becomes +6 all over 4. And 6 over 4 reduces to 3/2. So that's another combination of a and b. Okay, let's come up with another one. Okay, I could be creative here and flip the negative sign. I could make a -1 and b +3. Again, that works because I'd have -3 on the top all over -2 on the bottom, which reduces to 3/2. Okay. You probably get the idea that we can continue doing combinations forever and ever and ever. There's infinitely many combos of a and b that make this true. So this problem asks us to just write the equation of two of these possible lines, okay? So let's do equation 1, okay? So for equation 1, you're going to pick one set of these combinations, okay? So for equation 1, let's use a equals 1 and b equals -3, just because that's what comes first. Okay, so what you're going to do is you're going to build your equation. Okay, you're going to build your equation, and it's going to be f of x equals 1x squared minus 3x plus c. Okay, now to find the c value, that's what I don't know. That's the only thing I don't know. To find the c value, I'm going to actually use that extra piece of information they gave me, that it passes through the point 2, -2, okay? So now we're going to use 2, -2 to find c. So what that means is we're going to plug -2 in for f of x and 2 in for x. And we're going to simplify that. So we get -2 equals 4 minus 6 is -2 plus c. That's interesting. So we get c equals 0. So now what we can do is we can build that equation, and it's going to be f of x equals x squared minus 3x. And you can put plus 0 if you want, or you can stop right there. So that is one possible scenario that satisfies both of these conditions. Axis of symmetry of 3/2 and passes through the point 2, -2. Okay? So if we do this again, okay, if we do it again, and we do equation number 2, we repeat the same process, but this time we're going to use a different combination of a and b. So this time let's use a equals 2 and b equals -6. Okay, let's do a equals 2 and b equals -6. And I'm going to need some extra space here. So let me copy this. And let me move it over here. Okay, there we go. So equation 2, we're going to use a equals 2 and b equals -6. Okay? All right, so we've got f of x equals 2x squared minus 6x plus c. Now again, our challenge here is to find the c value. So we are going to use that point that was given to us. Okay, we're going to use 2, -2 to find c. Exact same thing we just did. So the function equals -2 when I plug a 2 in for x. So now we just go through and we solve this. So we get -2 equals 2 squared is 4. 4 times 2 is 8. Minus 12 plus c. So I get -2 equals -4 plus c. Add 4 on both sides, and I get c equals 2. So then I can build that equation, f of x equals 2x squared minus 6x plus 2. And that would be a combination that works. Now again, we limited this problem to just 2 possible scenarios. You could keep going. You could keep going. You keep using different combinations of A and B. And again, just to remind you, we did not randomly select A and B. We strategically selected A and B. Again, let me say that again. We didn't randomly select A and B combinations. We strategically selected them so that when I plugged those particular A and B values that I selected into -b over 2a, we got an axis of symmetry that was equal to 3/2. Okay? So guys, that's a really good quick overview of some things that you need to know about standard form of quadratic functions. I hope you found it helpful, and I look forward to seeing you next time.